Hello guys, welcome back. This is the second task from the Spark Foundation, and the problem definition given is from the given iris dataset, predict the optimum number of cluster and represent it visually. So here we have to predict the optimum number of cluster, optimum number of classes we are going to form during in a clustering algorithm, and we have to find the optimal number of that centroids, you can say. And the first we are importing the libraries, and I'm loading the data from my GitHub repository as URL. And here in the dataset we can see that these three, the length and the other variables, other features are treated as training variables, and another one as the target variable as species. In the model we are taking x as the our dataset from the this thing to from sepal length to the petal width, taking as the x training dataset, x dataset. And here we are just creating an list, empty list, and in this we are using the k-means functions, in which we are just iterating the single variable in our for loop as I 1 to 11. I will give you reason of or else it is written over here. We are taking 1 to 10 values as initial centroids is the centroids. We have to take some number of centroids. Okay, in the elbow core method we can say what is an elbow core method. In elbow core method we are just taking some number of range of centroids, and we are just finding out where we are having our best clustering classifications. In a graph we will see that graph in the following. So here we are just passing the each number, and we are training our model on that number of clusters only. The number of cluster over here is I will ranging from the 1 to 11, and we are training our model on that cluster only, and we are just adding the all inertia can be inertia or WCCS, like here in the second point it is written within clustered sum of the square, also known as inertia. We are appending that inertia into WCSS, and we will form the graph of it in the next implementation. Here we are just plotting a line graph, a simple line graph with the alpha matplotlib, and we are just taking the our x values as the range from 1 to 11, and the y as WCSS, which we have just founded in the above or within the clustered sum of the square. And we have also get this list from over here in our past implementation of for loop. And we are again, this is the okay, we'll just come to the graph, we will understand more better. So in this we are having, this is our graph we are getting from that, and here we are having number from a range from 1 to 11, or we can see this peak, this angle changing over here. After this we are not having some sudden change in our graph, and I also displayed that mode zoom over here. This will give us the, so the number 3 will be a perfect number, optimum number of centers we are going to have. In the modeling we are just, now we are passing the model as our 3 number of clusters in our model as 3, and we are fitting our data on that number of clusters only. And now we are just forming the final graph for just visualizing the clusters. So this is the task number second. Thank you.